Hello, and welcome to Grade.com Talks with. Today, we're talking with Kevin Carbonnier, project manager at New Buildings Institute, an organization pushing for better buildings that achieve zero energy, zero carbon, and beyond through research, policy, guidance, and market transformation to protect people and the planet. And if you're new to our podcast, please press subscribe button either on YouTube or your podcast app, because today we're going to learn about an organization that is a trusted and independent resource helping to drive buildings that are better for people and the environment. Hello, Kevin. Welcome to Grade.com Talks. We're excited to have you here.
Thank you, Karim. I'm happy to be here.
Wonderful. Could you please describe New Buildings Institute for someone who is not familiar with your work?
Absolutely. So New Buildings Institute is broadly focused on the building industry. So that's people's homes, our offices, and industrial buildings. And we're focused on bringing down the impact that buildings have on the environment and people. Buildings make up about 40% of the energy consumption in the United States and about 1/3 of the emissions, of CO2 emissions and others in the United States. So there's a very large impact that come from buildings, and we're working to bring that down in several ways. So one large one is focused on energy codes. So anytime a building is built, it must meet an energy code, and that dictates how efficient equipment must be, how efficient the overall building must be, what has to go on the walls. And the energy code is one piece of it. There's lots of other, there's fire and safety codes, for example. We're primarily focused on energy codes and moving those forward. And so states and cities will adopt these energy codes. And that means that all buildings built from then on have to meet this efficiency standard. So if we can advance that efficiency, that energy code, then we can have a really large impact on how buildings are built moving forward. So that's one area. And the other is a focus on, as you mentioned, zero energy and zero carbon buildings. And so these are state-of-the-art, the latest and greatest buildings that basically have no impact on our environment. And so what a zero energy building is one that generates on site as much energy as it consumes. And so these are buildings that you'll see that are typically covered with solar panels, for example, and are extremely efficient so that they use very little energy to begin with. And then over the course of a year, you can zero out your energy consumption. And so that's kind of been, the latest innovation for the past 10 years. And now the industry has really moved towards carbon, and we've seen this in national and international policy. We're not focused on energy so much anymore. Really, it's about carbon and meeting our carbon goals for climate change. Mm-hmm. And so we're transitioning to zero carbon buildings, and these are buildings that tend to also be zero energy, but will also offset other sources of carbon, which may be in the form of transportation to the building or carbon that's in the materials of the building themselves. So if you think like, I need structural steel for my building to build it. Well, it takes energy to mine the iron, to process, to transport, to melt that down, to get it to the site, the equipment on site to actually build the building. And so all of that has an impact that typically we haven't thought of in the past. And so we're working on all these different areas of the building industry, how they're built, how they're designed, and how they're operated to bring down that impact so that we can reach our climate goals.
Mm-hmm. Thank you for sharing the statistics that 40% of energy consumption is being consumed by the building industry, and 33% of carbon emissions is being emitted by buildings. And in general, that's quite a large number. And the power that the buildings industry has over sustainability and fight against climate crisis is quite huge. And the fact that your organization is working on building those energy codes and making sure to remove barriers to energy efficiency and on innovations you mentioned is very, very important, because if this is as indicated earlier, this is a huge portion, and even a 5%, 10% reduction can help us to have better environment and have better climate in general. Earlier, you mentioned that, and in your mission statement, it also indicates that you are working towards removing barriers to energy efficiency buildings. Could you please tell us what are some those barriers are that are in the way of building energy efficiency buildings?
Yeah, so there's a huge challenge for buildings, and that's that unlike, you might think of cars and you could have like miles per gallon limits for cars. Everybody, there's only so many cars on the road, and that same car is being produced countless times. For buildings, basically every building is unique. And so it's really challenging to come up with a one size fits all solution to bring down energy use in buildings, or to say use this technology because this will work. So the complexity is one large barrier. So what we do at NBI is to develop design guidance that's tailored towards addressing each of these problems. So that might be, what do I do in a cold climate? What do I do in a hot climate? What do I do in X, Y, or Z? And there's a myth that's sometimes substantiated that energy efficient buildings are more expensive. And that may be true up front. We do see, it could be a 0 to 3% sometimes increase in the total cost up front, but that pays back over, the 20, 50, or even 100-year life of the building. And so what we've done is work with lots of stakeholders, designers, local governments to make the case for energy efficient and zero energy buildings. And that's to say, what's the financial gain that you get from making this better building? And again, the analogy with the car is very simple, because, if you've got like a very efficient car, then you're going to spend less on gas, and then you'll make up, if there's additional cost up front. And that's the same, zero energy buildings, basically they don't pay any utility bills. And if you don't do that for 20 years, just think of how much savings that comes up to. So that's one. There's a lot of regulatory barriers as well. Advancing energy codes can be a challenging process. So NBI works at many levels, at the national, at the state, or even at the city level, to help local governments move their energy codes forward, so that they can get to these higher efficiency levels. And a lot of that has to do with, justifying the advances in energy efficiency with energy cost, which is one of the main factors that goes into that.
Mm-hmm. There are certainly a list of barriers that can go and go on when it comes to the barriers to energy efficiency buildings. But the most important ones were indicated by you, that is a perception of people that it can be very expensive. But while in reality, it's only initial costs can range up to 3%, where if you use the building for 50, 100 years going forward, then you will in general, it will be less costly, because you will not be paying much in utility, not in maintenance, and all of those other things. So you are advocating for long-term thinking, for long-term sustainable solutions for building, and that is very, very important. And you mentioned you work with local governments on advancing and enhancing energy codes. Could you please tell us, is there a unified energy code in United States, or is it all different based on locations? And how developed are those energy codes at the moment when it comes to energy efficiency buildings?
Yeah, happy to. So typically there are two standards for energy codes. One is ASHRAE, which is the associate. I might get this wrong. So ASHRAE 90.1 and ASHRAE 90.2 are the commercial and residential energy standards, and the other is the IECC. And so what states typically can do is adopt one of those two standards for their code. And so it becomes a code once the state adopts it, and then it becomes law. Some states like California or New York or Washington, and there are others, will adopt their own code, which tends to be based on one of those two, but they'll a lot of times make what they call amendments so that they can say, oh, we like this part of the code, or we want to push this part of the code further. So instead of this requirement, we're going to change this and that. So there's a lot of customization that states can do to these two kind of base codes that are kind of like your master recipe, if you want to think of it that way. And then some states will have what we call stretch codes, which really push things even further, and they can be 10 or 20% more efficient than these national level codes. In particular, Massachusetts and California tend to be leaders in those areas.
Mm-hmm. Wow, that's quite interesting that although there are standardized energy codes on the national level, yet on the state level, states can customize and trick and play with it, where some can advance it more, where the others can maybe push it down a little to enable non-energy efficient buildings. So that's very interesting comparison. And you, as your organization, advocates for better energy codes. Do you agree, or how do you work with the existing energy codes to enhance and advance them on the state and or city level, as mentioned earlier?
Yeah, so for these two, I mentioned ASHRAE and the IECC. There are committees that work on, each next iteration of the code. So these get revised every 3 years. Mm-hmm. And so there's some staff at NBI who partake in those conversations and how the next version of the code is going to, the standard, is going to change. And there are many different, it's a very multi-stakeholder process. So there's other organizations that are involved as well. So that many interests are at the table and talking about, how are we going to change these numbers? How do you address things like electric vehicles as there's changes in the industry now that buildings will have chargers more often? What kind of codes do you need to address that that connection to a changing world, for example? So that's the main process. At the local level, we can actually help states and cities write the code. So, you have this starting recipe. The state says, okay, we want our buildings in the year 2030 to all be zero energy. So we can chart out a roadmap of, okay, we know how to do zero energy buildings because, there's over 700 of them in North America right now. And we know where our energy code is now. And so what steps do we need to take to get to there? And that's where we can work with these local governments to chart a course for them to get to this goal that they have and develop resources around, workforce training or design guidance on, okay, if I'm an architect or an engineer, how do I make a building that actually reaches this level of efficiency? Well, that's where we can look to NBI to see, okay, we've got these resources that say we should use these types of technologies, have these considerations, and engage in this design process, and look to these further resources so that we can achieve this level of building performance.
Mm-hmm. As you are a think tank, a progressive think tank, when it comes to buildings, it's very important that you have a stake, you have a say in building and renewing those codes. Especially, you mentioned you work with states on actually writing those codes. So it gives us a hope that if the organization that is a think tank that is working towards energy efficient buildings is helping the states to mandate it, then there might be a positive change in the sustainability when it comes to buildings. You talked earlier about net zero energy and carbon neutral buildings and why they are important. Could you please tell us in detail the process of building such buildings? Does it take longer, or what are some challenges when it comes to building net zero energy and carbon neutral buildings?
Yeah, so the very first one is perceived cost, as you would probably guess. And I mentioned that sometimes there's no cost increase, sometimes there's a small cost increase, and the reason there's a variability is because it depends on the local market. It depends on the building. As I mentioned, every building is unique. So you could have a very simple building that's zero energy, or you could have a very complex building that's got very detailed finishes, like those types of things. There's so many factors that go into determine the final cost of a building. So I lost my track. Remind me, where was your question?
Yeah, what are some how the process is different when it comes to building net zero energy and
Right.
neutral buildings?
So the process isn't always that different. There's a kind of a code baseline building, which we call is like, that's, you're just following the rules, and this is like your basic, least efficient building that you can get away with, essentially. And then there's an energy efficient building, which has things like increased insulation, better air tightness, higher efficient equipment. There's things like energy recovery, so that, if you're in a very cold climate, it's warm inside, it's cold outside. We need to bring cold outside air, so we get like fresh air for humans. Let's use some of the heat in the building to warm up that air that's coming from the outside. And you would think that's kind of like a no-brainer, but a lot of buildings don't do that because it's not necessarily required. So there's advanced technology, there's more insulation, there's better air sealing. So sometimes the construction quality is important, so that, things are built appropriately. And then obviously the renewable energy is the biggest difference, because to be a zero energy building, you need to have renewable energy. And typically that will mean having PV on the roof.
Mm-hmm.
And so that can offset the energy use of the building. But we're seeing challenges there as well, because very tall buildings have a small roof and a lot of floor area. And so there are other solutions, like buying into a community solar farm, for example, that we're seeing more and more in the country. I know here in Oregon, I see tons of solar farms whenever you go out on the highway. And so rather than having it on the roof, they say, okay, this portion of the solar farm, that energy is going to my building, so that my building can be zero energy. And so we see this community-based approach for buildings that can't physically reach zero energy on site, because they just don't have enough room for solar panels.
Mm-hmm. Although in the initial process, when it comes to codes, might be similar, yet there is more advanced technology involved when it comes to net zero energy and carbon neutral buildings, as well as more renewable solar panels, which is eventually is very sustainable and helps us in the fight against climate crisis. As the organization, besides what we discussed earlier, focuses on building innovations, could you please tell us some of the current building innovations besides net zero energy and carbon neutral buildings that the industry is working on?
Yeah, there's been a lot of change in the industry in the past 5 years or so. Mostly it's been the transition from energy to carbon. Mm-hmm. But now there's also a very important change coming, and that's the evolution from what we call operational carbon. So that's carbon emissions that are associated with the energy use in the building. So that, whenever I turn on the lights, that energy is generated at a power plant, and that power plant, may be solar or wind or renewable, or it may be natural gas, which means there are emissions associated with it. But as I mentioned earlier, there's also embodied carbon, and that's carbon that's associated with the materials themselves, and the extraction and the processing and the building of the building and transporting those materials to the site. And what we've seen is that over 20 or 30 years, the embodied carbon in a building can be basically the same impact as the energy use of the building. And so these energy codes, they all bring, they give you more energy efficient buildings. They use less energy. Owners pay less in their bills. They tend to be more comfortable, but that doesn't address the embodied carbon in the building, which, as we get more efficient buildings, the embodied carbon piece actually becomes more and more important. It's a larger piece of the pie, and it's one that we have to address if we want to get to our climate goals. And so this is the big shift now, is focusing on green materials, such as constructing with wood when possible, or adjusting the way that we mix concrete, so we can have additives for concrete, or replace some of the ingredients in concrete to reduce the embodied carbon in that concrete. And similarly for steel, which is another big contributor, is the way the steel is manufactured can greatly impact the embodied carbon in that steel. And so that's a big innovation. It's not in the codes right now, but NBI and others are working on introducing that into codes. There are some local jurisdictions that have adopted limits for some materials. Typically, concrete is the first one. And so we'll say, if you have concrete, it needs to be below this amount of embodied CO2 per kilogram of concrete, for example. And so that is expanding throughout the country. More and more jurisdictions are addressing embodied carbon. I know here in Portland, they've done some pilot tests to compare traditional concrete versus low embodied carbon concrete for things like sidewalk ramps. And that's not even going in the building. And like, it doesn't matter to you or I what kind of concrete is in the ramp on the sidewalk, right? As long as it works, it works. And that's just one way that we can get all these savings, and it basically doesn't cost anything. And so it's been invisible for a long time, and it's really coming to the forefront now. And so it's an exciting development, and there's a lot of movement to address this embodied carbon piece in buildings.
Mm-hmm. It's quite interesting to see that the innovations that is currently being done in the buildings industry itself is you guys are focusing on the whole supply chain itself, in the production of the buildings, in the way the buildings are built, the materials, and focusing more on the green materials, and raising awareness on the impact that the other types of carbon have on the environment. And you are finding working together with the industry representative generally on finding better solutions and more effective, more long-term solutions. So it's great to see that there is, although it might be invisible for someone who is not from the industry, yet it's very, very, very important to realize those the key changes, the key differentiator in the building innovations at this moment is in the supply chain. If someone would like to support New Buildings Institute, how can they do that?
I'm glad you asked. So NBI, as you mentioned, we're a nonprofit organization. And so you can support us by donating at our webpage. That's newbuildings.org/donate. And also just having an increased awareness of the impact of buildings and the opportunity that they present in reaching our climate change goals. That helps build momentum to transform our building stock, to have more owners asking for buildings that have increased energy efficiency, lower embodied carbon, and all these things that will help us get to our currently very small budget that we have left of carbon emissions to reach this 1.5 degrees Celsius warming that we're all trying to stay at or below.
Mm-hmm. The link to the New Buildings Institute website will be provided in the description. So you viewing and listening can go to the website and familiarize yourself with the great work Kevin and the staff at New Building Institute is doing, and make a financial contribution if you wish to. Thank you so much, Kevin. It was wonderful to get to know you and the great work a New Building Institute is doing.
Thank you, Kareem. This was a great time.
For you listening, if you enjoyed this conversation, please press like and share button, because this will show the YouTube and podcast algorithm that this conversation is important, that we need to build more energy efficient buildings for the people and for the planet. Thank you, and see you for the next episode.